In this video, I'm going to show you how to do a chi-squared two-way test on the calculator. This could be either a test of homogeneity or a test of independence. The first thing we have to do is set up a matrix with all of the cell data values. So I'm going to use the example with the dark chocolate and the milk chocolate in our second example from our notes. So the first thing I'm going to do is I look and I see, actually let me go to that problem. Here's the data I'm going to be using, and I'm going to be entering these cell values in here. So just the actual data, not the totals. So if we count, this is a 1, 2, 3, 4, 5, 6. So this is a 6 by 2, 6 rows and 2 columns, a 6 by 2 matrix. So going back to here, I'm going to go to this button right here. And notice I've highlighted this particular matrix button. Then we're going to put in the number of rows. So we have 6 rows, we have 2 columns. So now we'll fill in the values for that matrix. So 78, you can just tab in between. So just take a minute to do this. You might want to do this along with me, so just to practice, make sure you know how to do it. Maybe I should sing or something while I'm doing, or just, I don't know, I'll just mutter and talk while I'm doing this. Okay, now I need to also store this and name it something. So I'm going to push Control Variable to store it, and I'm just going to pick a variable to store it to. And I'm going to call it O because it's the observed matrix. You can just call it one letter, but these are the observed values. You can call it whatever you want to. Okay, now that I have all of my matrix values stored, or all of my data values stored in a matrix, it's time to run the test. So I go to Menu and Statistics and number 7, Stat Test, and go to a chi-squared two-way test, which is number 8 down here. And the observed matrix is just put the matrix in, which is O, and it says argument must be a matrix. I must have hit 0 instead of O. So let's try that again. Menu, Statistics, Stat Test, 8, Observed Matrix, O. Okay. So here's all of our information. We have our chi-squared value, 56.6. We have our p-value, 6.05 times 10 to the negative 11th, very small. So I'm going to be rejecting my null hypothesis. My expected matrix. Now I want to know, notice that I didn't have to calculate my expected values. My expected values have been calculated for me, my expected count. So all I have to do is go to Variable and find where it says expected matrix and then push Enter. Those are all the expected counts. Now I also would like to see my component matrix. So my component matrix, go to the Variable button, go down to Component Matrix, and I can see which of the values are the largest. So you can see right here the biggest differences occurred in line 1, which were the brown M&Ms, and line 4 here, which were the blue M&Ms. So the blue and the brown seem to be the culprits here with creating a large chi-squared value and causing us to reject the null hypothesis. So in this case, we would reject the null hypothesis and say that the distributions of colors for dark chocolate and milk chocolate do not seem to be the same. In particular, we notice that the dark chocolate seems to have a higher percentage of brown, and the milk chocolate seems to have a higher percentage of blue. So those are the ones where we noticed the biggest difference. Notice we can't always tell the biggest differences just by looking at the expected values and the original values. We might be able to tell by looking at those, but the components really highlight which ones are the differences.